Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing gated D-latch, or simply we can say D-latch. This topic is from sequential logic circuit. The subject name is digital electronics. Let us see the circuit diagram or the logic diagram of gated D-latch. We are familiar with SR latch. This is a diagram of SR latch having 4 NAND gates, S, R inputs, and then cross coupled with these 2 NAND gates. The modification of this SR latch is we are connecting one extra input known as D and is connected to a NOT gate. When we connect both the ends of the NAND gate, it becomes a NOT gate. So, the D input is directly given to the S input and D input passing through a NOT gate is given to the R input. This is additional modification done to make it as a D latch. So, it is having 5 NAND gates, D input. Let us label it as S and this one as R. En is the enable input, Q and Q bar are the outputs. The logic symbol for D latch is D input. It is a single input latch and one enable input to enable the latch to make it on and off, and 2 outputs Q, Q bar. And as you are knowing about NAND gate, this is a symbol of a NAND gate and its truth table. If A and B are the inputs of this AND gate and Y is the output, the truth table for NAND gate comes to be as 0 0 0 1 1 0 1 1. What is an AND gate? When any one of the input is 0, the output is going to be 1. So, for 0 0 it is coming to be 1, 0 1 1, 1 0 1, 1 1 0. When both the inputs are high, when all the inputs are high, the output is going to be 0. This is the truth table of NAND gate. If you remember this, it will be easy for you to understand the working of the D latch. Okay, now let us see when the enable input is 1. This enable input is 1 and D is 1. So, let us see this in condition when the enable is 1. Let me keep it like this so that it will be visible. Okay. Enable is 1 and D is 1. So, what happens now? Enable is 1, D is 1, both are 1 1. What will be the output at A? It will be 0. It will come as 0. Okay. Now, here the enable is 1 and D is 1. So, when it is passing through this NOT gate, it becomes 0. So, for 1 0, what is the output at B now? It is 1. So, here it is 0. When any one of the input of NAND gate is 0, what is the output? It is going to be 1. Okay. Now, what happened? This 1 gets coupled over here. So, this 1 1 becomes 0. Is it clear? So, what is the condition here? Enable is 1 and D is 1. So, when enable is 1 and D is 1, what is the output coming? Output is going to come as 1. Okay, and what is Q bar coming? Q bar is coming as 0. Now, let us take the second condition. Enable is what? It is used to make the latch on and off. So, we will make it on as 1 and now let us make D as 0. So, when D is 0, what will be the input here? S will be 0. S is 0, enable is 1. When passed, now D is 0. When coming through this NOT gate, it will become 1. So, both are 1 1. What will be the output here? It will become 0. Okay. So, when this output is 0 at this B input, what will be this now coming? When any one of the input of the NAND gate is 0, the output is going to be 1. Now, this 1 is going to be coupled here. Okay. So, what is the output here now? So, this is 0 1, for 0 1 the input output is going to be 1. So, now both the inputs are 1 1. What is the output here? 0. So, what happened? When the enable input is 1 and D is 0, Q is now coming to be a 0, and what is Q bar coming? 1. So, it is easy to remember for a D latch, whatever is the D input, the same is going to be the output. So, D is 1, so output is 1. D is 0, the output is going to be 0. It's only for remembrance, but in coming to the working of latch also you can easily do it by remembering the NAND gate truth table. The summary for the working is when the enable is 1, D is 1, output is going to be 1. Enable is 1, input D is 0, the output is going to be 0. So, let us see the truth table for the D latch. It is written as, we will have two inputs D and Qn. Qn is a present input. The D input can be either 0 or 1. To work for the working of latch, we have to keep the enable as 1 all the time. So, when enable is 1 and D is 0, what is output going to be? 0. Irrespective, we kept the Qn, the present state is don't care. It means that it is not depending on, the output is not depending on the present output. This output is directly depending on the present input. Qn plus 1 is the next state. So, when enable is high, D is 0, the output is going to be 0, the next state is going to be 0. So, D input Qn plus 1 is 0. So, for 0 it is leading to 0, so we can call it as reset state, and when D is 1, the output is going to be as 1, which is known as set state. Now, we made this enable input as 0, that is a switch, this latch is off. So, whatever input we give at D, it is not going to work. So, we will say that it will be in the no change state. So, what will be the next state showing? It will be showing Qn. So, when enable is 0, whatever you are going to put here for D, whether it can be 0 or 1, so we kept it a don't care here. Okay. So, when the enable is 0, the state of the D latch will be no change state, or we simply can write it in another form, this truth table like this. We can write the truth table for two variables, input variables D and Qn. Qn is a present output, Qn plus 1 is the next output. So, two input variables are D and Qn. So, two variables, we can have four possible states written as 0 0, 0 1, 1 0, 1 1, that is 0 1 2 3 states. Okay. And the enable is all the time held 1, so that it works, it is on. Okay. So, what will be the output of the D latch now? Whatever is D, the same is going to be reflected at Qn plus 1. So, D is 0, Qn plus 1 is 0, D is 0, Qn plus 1 is 0, D is 1, Qn plus 1 is 1, D is 1, Qn plus 1 is 1. So, it is not depending on Qn. So, whatever is D, the same is reflected for Qn plus 1. When we draw the truth table, when we draw the K map for this characteristics table, we get the characteristic equation. Let us derive it. So, we are having two inputs D and Qn. This is Qn 0 1, D 0 1. Now, while filling for Qn plus 1, we are solving it for Qn plus 1. So, it is 0 0 1 1, and we have grouped this 1 like this, and it is coming to be as 1. For this pair, it is coming to be as D. So, what will be the characteristic equation of Qn plus 1? It is coming to be D. It is very easy for remembrance for D flip flop. When enable is 1, D is 1, so output will be 1. When enable is 1, D is 0, output is going to be 0. The characteristic equation of D latch is Qn plus 1 is equal to D. Okay. Now, let us quickly have a comparison between SR latch and D latch for your quick revision. This is a SR latch and this is a D latch. What is the difference you can find? There is only this special one extra input is added to this SR latch, 4 NAND gates, and to this we have used a common input D input giving directly to S, and another one is negated through this NOT gate and is given to R input. So, the modified form of SR latch is D latch. Coming to their truth table, the inputs are for SR latch 0 0 0 1 1 0 1 1. When both the inputs are 0, Qn plus 1 is going to be Qn. When it is 0 1, it is going to be the reset state, 0 reset state. When S is 1, R is 0, output is going to be S1, which is known as set state. And when both are 1 1, it is indeterministic state, that is we do not know, it is undefined. Okay. So, this Qn is known as no change state. So, no change, reset, set, undefined. Here all the time the enable is made as 1 to make the SR latch work. Coming to D latch, whatever is the D input will be reflected at Qn plus 1. D is 0, Qn plus 1 is 0, D is 1, Qn plus 1 is 1. The enable input is made as 1. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.